Hello students, welcome back after a long time as I was busy with my some other stuffs and work. We'll be continuing further on LTSPICE and learning more on these tools. So today we will see transient analysis, AC analysis and DC analysis all in one tutorial so that you will not require to switch to another tutorial again and again, and in a one go you can understand the difference and how to take the output of a single circuit in 3 to 4 different manners, like we will see one .op command also. So let's start and let's see uh, how we can make it happen. So first of all, open your LTSPICE tool, open a new schematic. We will take a simple half rectifier circuit and understand all the analysis followed by one. So as of now, you must be familiar of how to use the LTSPICE. If not, then please go to my previous commands and tutorials, which consist of the components and introduction to the tool. But again, I'll just give an overview here also, that this is the schematic window which you are seeing right now. Then from here you can get the component. Then this is the diode, this is the inductor, capacitor, resistor, and labeling and grounding, wiring, and moving and dragging. So these are all shortcut keys. And if you need to insert any comment, then go to the text, and to run a directive you need to go to the .op command. So for running the simulation, you will see running it by this button, and moreover, we will see more while practicing one by one. So let's make and begin with a circuit. First of all, I am taking a diode. How you will rotate it? Control R. Okay, fine. And releasing it is escape. I'm taking one resistor here, escape, and then we'll need one supply voltage. Voltage. Okay. So first we're gonna see a transient analysis, right? And of course we need one ground and escape. Take a wire, connect these components. Okay, it is done. Then let's give this some values. We'll pick a new diode. I'm taking it is 1N4148, and okay. The value to be as 2 kilo ohm. Okay, and then the sign voltage. Okay, DC voltage. Instead of giving a DC voltage, I will get it. Take your cursor to here and then right click. Will not be giving right now DC voltage. Go to the advanced setting. We'll be giving a pulse. There's a sign, and here we'll be giving offset as 0, amplitude as 5, and frequency of, let's see, 2 kilohertz. And okay, fine. Then let's run it. So transient analysis, I am giving a run timing of 4 milliseconds. So this is how your cursor behave in a state of to measure the current, and this is how it will look like to measure the voltage. So now here our circuit is ready, and now we'll see how it will look like. We'll run it and see the input waveforms. So you can see it is running for 4 milliseconds. The time axis, x-axis is a time axis and y-axis is a voltage axis, and the voltage is going from peak to peak of 5 amplitude, which we had given. And at the output, let's see what happens. Okay, you can see that negative cycles is clipped off, hence it is working as a half wave rectifier. Then the diode is the difference. You will see that it will give a difference of drop of 0.7 voltage, which is the cutoff voltage of this diode. So this is how you'll do a transient analysis. You can also comment it as a transient analysis. Okay, so this was your complete transient analysis. Now let's move on towards the DC analysis. So we will modify this circuit itself so that you can understand its difference one by one. So let's close this result waveform window and maximize this. A little bit zooming it in for you. Let's change the comment to a DC analysis. Okay. So here this will go. You can also do it by taking a scissor and cut it off. We'll change the voltage. So here first we will do none, and DC value I'm giving as a 5 voltage. Okay, so now it will remain constant. Now let's see uh, by running it. Okay, directly from here also you can type dot op. Other than the second way is dc dot op. Okay, you directly take this command. Okay, so here you can see some voltages you can. Okay, at V out there is a drop of voltage and you are getting as 4.379. So 0.7 if you add you will get a voltage of 5, so 5 volt. So there is a drop of 0.7 voltage due to the presence of this diode, and it is showing the current at D1 diode, then current at R1, then current at V1, and then voltage at V node 001. It is V1 only. Okay, so this was your DC analysis. Hope you are clear with it. If you have any doubt, please comment in the comment section. Now let's switch to the next operating point. What is the next operating point? That is a DC sweep. So DC analysis directly dot op is different than DC sweep. And okay, let's see how can we make the changes. Take the scissor and cut it off. So we'll be sweeping the voltage. So for that you will take DC value I'm giving as 5 only, and then we will run it for DC sweep of some. The sweeping voltage is V1 that I need to sweep. Take a linear start value, I'm giving it as -5, stop value maybe 5, and incrementing it by 0.1, right? Then okay, let's see what happens. You can see that the x-axis is varying from -5 to 5. Okay, so it is constantly varying from -5 to 5 with the variation and increment of 0.1 voltage. And let's see at the output what happens. Okay, output will be getting as a voltage as this. That is there is one point that is near to 0.7 0 voltage, it is not conducting, but after let's see using a cursor, after a certain voltage of maybe 0 point something 7, that is a 67 or millivolt. Okay, so that is 0.7 voltage. You can see that the diode starts conducting, and this is the voltage across diode will get. It is little bit less than the maximum voltage that is applied. You can see we are getting it around 4.357 voltage of volt across a diode. And let's check for current also. Okay, so this is the current, and you can also cross check it as like IV characteristics of diode. We are getting the IV characteristic of diode, right? Voltage at the x-axis, and at the y-axis you are getting a current. So hope you are now clear with the DC sweep analysis also. So what we have seen until transient analysis, then dot op, that is direct DC voltage analysis, then third is DC sweep analysis, and now last analysis we must be waiting for is the AC analysis. So AC analysis is basically frequency response of the circuit. We'll close this waveform and we'll maximize this. First, we'll comment it, change it to the AC sweep analysis. Fine. And okay. And then I'm cutting it off. Okay. And escape it. Advance. Let's give a pulse of amplitude, AC amplitude of maybe 2 voltage. And then okay. Cancel it. Okay. Only AC voltage of 2 amplitude. Resistors to be 2 kilo ohm only. Let's see how we can run AC sweep. So you click on run, go to AC analysis. I'm sweeping it as an octave curve. The number of points I'm taking maybe 10. Start frequency I'll take is 60. Stop frequency maybe 600 hertz. And okay, fine. That's at the input end. This is the voltage at the output end. So here you can see what is happening is x-axis is the your frequency axis, right? And your output voltage is in dB, that is given on the y-axis. And one line axis you can also see at the right hand side, that is given in degrees, that is a phase axis. So here you can see that the solid line shows the amplitude waveform of the transfer function you are getting, and this dotted line shows the phase response of the circuit or the transfer function you are getting, right? Now if you want to remove this, you can right click on here, and if you want to remove this, you can just click on don't plot phase, and okay, then phase will be removed, but it is better to get a complete view of these things. And then if you want to see in a Cartesian form, you can go here and click OK. Hope you got it what I did. See, go to the left hand side axis, that is a y axis, click over here, right click over here, and in the representation from body, go to Cartesian and OK. So now from Bode you have converted, that is a 20 log of voltage, whatever output you are getting, it is converted into voltage form. So this is in a micro voltage you are getting, and your x-axis is in hertz and y-axis in your voltage, and the solid line is your amplitude line, and the dotted line is your phase line. How much lagging or leading by the component. So this was your AC sweep analysis. Hope you have now are aware of all the three analysis, that is actually four analysis. So that is DC sweep analysis, transient analysis, dot OP, that is direct current DC, applying direct DC voltage, and then and the last one is AC sweep analysis, that is the frequency response of your circuit. I request you all to practice it. It doesn't come across unless and until you practice it by your own. So in the next tutorial, we'll come up with more different complex circuits with more analysis, which will be advanced analysis based on these the basic analysis which I have shown today. So this tutorial is very important. Till then, I request you to please stay safe and keep learning, and also keep sharing if you really liked the content of the channel, in case of LTSPICE tutorials. And also comment me in the comment section that if you have any personal requirement or any aim which you are stuck in with, in case of LTSPICE or any other issues. So thank you very much. Till then, thank you.